Good everyone, my name is Graphics. In this video, we want to solve a problem involving fluid mechanics. We'll be looking at an aspect of one of the properties of fluid mechanics, which is pressure. I'll be taking a look at an hydraulic press. And the problem goes like this. It says the diameter of a ram and a plunger of an hydraulic press are 200 millimeter and 50 millimeter respectively. Determine the weight lifted by the hydraulic press when force applied at the plunger is 350 Newton, and what altitude should be in order to begin to raise the weight by pouring oil into a thin tube. Take density of oil to be 790 kilogram per meter cube. Now, if you look at an hydraulic press from the diagram that is being displayed on the screen, it will help us to raise a load by applying a little force, right? And these are some of the basic principles that we use in constructing of what our brake, right? So I won't go into details on that. We'll just go straight to the question here. Now, if you look at this hydraulic press here, we are given that this is the plunger here and this is the ram here. Now, we're expected that when we apply a force at this plunger here, right, the force we apply here, no matter how it is, should be able to raise any load that what is being placed on the ram here. The ram is like a lift. It helps to, when you apply force here, right, there's a pressure that is going to affect this plunger. So a downward force here will result to what? An increment of the pressure here, right, which will help to what? Increase or to raise this load at the ram here. Now, the first thing you have to do here is to write out your parameter. Now, one of the parameters here given is, it says the diameter of the ram and the plunger of the hydraulic press are 200 millimeter and 550 millimeter respectively. So you write diameter of ram, we use it to be D1 equals to 200 millimeter. You convert it into meter by dividing it by 1000, and that will give us 0.2 meter. Now, since you calculated for you've gotten since the parameter for diameter is given, now you need to calculate for what? For the area. Now we know that the area at this same ram here, we'll give it a subscript 1, is given to be what? Pi d1 square over 4, because it is circular, it is a pipe. So the surface area, right? So if you input your parameter here, we know our pi is given as what? 22/7, which is equivalent to what? 3.142, multiplied by the diameter of the ram, because that is what we're actually talking about. So we say the diameter is given to be 0.2, then raised power 2 divided by 4. So the answer here will give us 0.03142 meter square, because area is measured in what? In meter square. Now similarly, we are given the diameter of the plunger, which we use subscript D2, is given to be what? 50 millimeter. So you convert it into meter by dividing by 1000, and we're going to be having 0.05 meter. Now we will now calculate for the area of the plunger, since the diameter of the plunger is given, and that will give us subscript A2, that will be pi d2 square over 4, and this will be equals to 22/7 multiplied by 0.05 square all over 4, and we know 22/7 is given as 3.142 multiplied by 0.05 square over 4, and that will give us 0.00196 meter square. Now you need to understand, you can use whatever parameter you want to use to represent your diameter. You can try to use the capital letter, or you can use the capital letter, subscript D and 1, anyone you want to use, it's fine. But when you are starting to use any parameter, ensure you specify that T1 is diameter of the ram, D2 is diameter of the plunger, A1 is area of the ram, A2 is area of the plunger, to make things easier for both you and whosoever is marking your script. Now we move further. We are told to calculate the weight lifted, and we use W1, W subscript 1 as the weight lifted, or we can just use W, right? And when you say the weight lifted by the hydraulic press, that is the weight lifted by what? By the ram, right? So I'm using W to represent that. Now, similarly, the force applied at the plunger. So the force F applied at the plunger is given to be what? 350 Newton. And I'm using what? F to represent the force applied at what? At the plunger. Now, the height of the plunger, we are told that we should look for the altitude. That means the height. How high will you raise the plunger for it to raise that particular load of what? 350 Newton, right? So we'll say we use our H to represent the height, and we are given that the density of the oil to be 790 kilogram per meter cube. That's the density here. So now what we'll do is, let us write this out. We know very well that the pressure intensity due to the plunger is given to be what? P. So I'll be using, since we're talking about plunger, I'll be using subscript 2 to signify that we're talking about what? The plunger, the pressure of the plunger. Equals to what? We know pressure is given as what? Force per unit area. So it will be the force at the plunger all over what? The area of the plunger. So I'm using subscript 2 to signify that I'm talking about the plunger, right? I'll call that equation 1. Now, similarly, the pressure intensity due to the ram, we use subscript 1, P subscript 1 to represent it. Since we're talking about the ram, is given as what? Force per unit area, which will be F subscript 1 all over what? A subscript 1. Now, and we know that when we talk about the force at the plunger, we're talking about the weight lifted by the plunger, because weight is a kind of force that acts downward, right? So I'm using W to represent my F, since we're talking about the weight at the plunger. So the force at the plunger is the weight at the plunger, right? That's the weight lifted by the plunger. So the area all over the area, I'll use A1 here. So this is what we have. I'll tag that to be what? Equation 2. Now when you look at this closely, equation 2, you can pick any one, but there's something you have to look at before you pick any equation here, right? We'll call it an equation because we have many unknown. Like if I look at equation 1, now you ask that question, you're going to answer this for me. If you look at equation 1, we have pressure, which we know, which we don't know. We're looking for that. We know the force F2, right? Which is the force at the plunger, and we know it is 350 Newton. Then let me just input it there. Now the area A2, we know it also, which is given as what? The A2 here is given as 0.00196 meter square. Now we have 2, we know the 2 parameters there, so we can easily use equation 1, because when you have less than 2 unknown, right, you have just only 1 unknown, you can actually use the equation. But when you have more than 1 unknown, then it will still remain an equation. So I can use equation 1. Why can't I use equation 2? This is the reason here. We know the pressure, right? We don't know the pressure P1. We only know the pressure P2. We don't know the pressure P1. We know the force. We don't know the force at the ram. We don't know the force, meaning we don't know the weight at the ram that is being lifted by applying the force of 350 Newton, but we know the area. Now, if you look closely, we have 2 unknown, which is the pressure and what? And the area, right? Which is what? The pressure and the area. So from here now, let me stick to my words, my equation 1. Now, sticking to equation 1, right? We're told that the pressure intensity P2 is equals to the force all over what? The area, right? I know the force at the plunger is 350, all over the area of the plunger is 0.001964, and this will give us 178,207.74 Newton per meter square. Is that taken? Now we'll move further. Recall, we know that the pressure at the ram is equals to the pressure at the plunger, and that is Pascal law, which says that what? The pressure intensity at a liquid at rest, on a liquid at rest, is equal in all direction, right? So whatever pressure is applied at the plunger will be the same pressure at what? At the ram. That's what I'm trying to tell you here. So from equation 2 now, we know that the pressure at the ram is equals to the weight lifted by the ram all over the area of the ram. So that's what we have there. So now we know that our P1 is equals to what? P2, and that is what? 178,207.74 equals to what? The weight all over what? The area, which is given as 0.03142. So if I make the weight of the formula, I'll be having 178,207.74 multiplied by 0.03142, and my weight will now give me 5,599.29 Newton, right? Now similarly, the weight lifted by the ram is 5,599.29 Newton. So for the next question here, we're told to look for what? For the altitude, right, which is the height. So recall, we know the pressure intensity is equal to what? The specific weight multiplied by the height. So, but specific weight is giving us density times gravity. So the pressure intensity now will now be giving us density times gravity times height. And what is the pressure? 178,207.74, which is equals to the density is given to be 790 multiplied by 9.81 multiplied by the height. 9.81 is a standard, the constant for gravity, right? So now if you do the needful, we'll be having 178,207.74 equals to 7,749.9 H, right, when you multiply that. So making H is the formula, we're going to be having 178,207.74 all over 7,749.9. So the H here now will now be given as well 22.99 meter. So meaning that the height that you must raise the plunger in order to apply a force of 350 Newton that will lift a load or a weight, right, of that will lift the weight of 5,599.29 Newton is 22.99 meter, right? So these are the needful. This is what we are told to look for. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.